In this video tutorial, I'll be recording how to solve the Term 2 practice questions suggested for grade 9 ASP for their end of term exam. So let's begin. First with the subtopic of 4.2. What is a phase change? A phase change is when a substance goes from solid to liquid to gas and vice versa. So it's a process or it's a transition between the three physical states. The chemical composition of the substance during this transition does not change. It remains the same. How does a phase change occur? A phase change occurs by not alternating the atomic structure, and it's not related to pressure. It is simply where the substance will gain or lose energy so that the intermolecular forces becomes stronger or weaker, and then it can shift from solid to liquid to gas. So it's by removing or adding energy so to allow for this change to happen. Describe the relationship between energy addition and temperature change in a material. So how does adding the energy to a material affect its temperature during a phase change? You need to understand that if this is the phase change, here the temperature is increased all the time, but during the phase change itself, the process itself, the temperature remains constant. And at that point, it's where the energy gained is helping the material, the substance, to break the intermolecular forces and shift from solid to liquid to gas. So during the phase change, the temperature remains the same. So here is the phase change happening. This is the transition from solid to liquid while the process is happening, and this is the process of happening while the substance changes from liquid to gas. So during those changes, the temperature does not change. Definitely, it's the energy working at that point. So the temperature remains constant, and the energy at this point is working on breaking the intermolecular forces between the particles to shift it from solid to liquid or to liquid, from liquid to gas. I would like to point that in those parts of the diagram, here temperature increase and the kinetic energy obtained is not used to change the phase or the state of the substance. Let's move on. What type of energy is associated with the movement of particle? Anything related to movement is kinetic energy. During melting or boiling, so during the process, the temperature of a substance remains constant. Yes, because again the energy is used to break the intermolecular forces between the substances so that they can change from solid to liquid or liquid to gas. Observe the heating curve of water, ice, steam, liquid, steam, during which segment is most heat required to change water from one phase to another. If you note here in every phase diagram of water, this segment is always smaller than this segment. So here they're not talking about a physical state that persists. So here they said in which segment heat is required to change from a phase to another. So we're looking at those segments because in this segment there is no phase change. So it's still in the same phase change. So segment 4 is larger. Now why segment 4 is larger than segment 1? In segment 1, the intermolecular forces are changing to become weaker from solid to liquid. So we just want the intermolecular forces to loosen a little bit so that the particles can start sliding past each other instead of moving in their place and vibrating in the solid phase. But in segment 4, the intermolecular forces need to break completely, because to shift from a liquid to gas, particles need to be free and move randomly in all directions, and at this point the intermolecular forces are almost negligible. So that's why it requires more kinetic energy to break all of the intermolecular forces, and this is why it is longer. What does a flat section of a temperature versus energy graph indicate? A flat section means that the temperature is constant. It means that the material is undergoing a phase change. Okay? Energy is always added, it's just the temperature is constant and it's going through the change itself. What happens to temperature during a phase change? Again, it stays constant. How would temperature change if energy is continuously adding after a material has fully melted? So let's look. If a material has fully melted, so it's here, a material fully melted, what happens to the temperature? The temperature will start increasing again. So here, the temperature will continue to rise as the material becomes, after the material becomes a liquid. I think there's a typing mistake here. So it's gonna increase again. Consider the heating curve for certain substance below to answer questions 10 to 7. Is the substance being heated or cooled? Since the graph is going up, the substance is being heated. If I see a graph like this, the substance is being cooled. How many states of matter are present? I'm going to keep it here. So how many states of matter are present in this graph? This is a state of matter of solid. This is the state of matter, that's the section for the state of matter of liquid, and that's the one for gas. So in this graph, we observe 3 states. During which segments does the graph show no increase in kinetic energy or motion of the substance molecules, but there is an increase in their potential energy, their intermolecular forces? So here, the average kinetic energy of a substance is the definition of temperature. So I'm going to write it here. Temperature is the average kinetic energy of a substance. So when they tell you in which segment shows no increase in the kinetic energy, they mean by this no increase in temperature. So, and there is only an increase in the potential energy, and which is working on the intermolecular forces. So it is in segment 2 and 4. During which segments during what segments does the graph shows increasing kinetic energy? So it's the other part of the graph. So it is 1 and 3 and 5. The substance is all liquid in which segment? In 3. So here all I have solid. Here all I have is liquid, here all I have is gas. But in this part of the segment, I have liquid and gas together. And in this segment, I have solid and liquid together. So the next question, in what state of matter is a substance during segment 1? In what is the state of matter of segment 1? It is solid. What phase change does the substance undergo in segment 2? The phase change is called melting. The process is called melting. It's a change from solid to liquid. Which segment represents the existence of the substance as a mixture of liquid and gas? It's in IV. What is the difference between evaporation and boiling? Well, both of them will shift the substance from liquid to gas. But the difference is that evaporation happens start taking place below the boiling point temperature, whereas boiling happens at the boiling temperature. Now, one more thing. If I have a container that is liquid, I have the particles at the surface. Those particles, they will have always a higher kinetic energy than the particles in the middle of the container. So these are the ones who will gain enough kinetic energy and start escaping to the gaseous state. So when we are differentiating between boiling and evaporation, evaporation starts or take place at the surface of the liquid. But once boiling starts, it starts taking place everywhere. So boiling occurs at the surface and throughout the liquid. So that's the main difference between them. So here, evaporation occurs only at the surface, while boiling occurs throughout the liquid. Evaporation doesn't happen in a closed container. It doesn't involve bubbles. And it definitely not at the boiling point temperature. Which of the following factor does affect the vapor pressure? I would like to point out that when I have a liquid in a closed container and I am heating this liquid will start turning into gas. Now this gas, since there's nowhere else to escape, it's gonna start building up as gas particles on top of the surface of the liquid. So that's what we call vapor pressure. It's the pressure caused by the vapor that was obtained from the boiling. Okay? So which factor affects the vapor pressure? It's only the temperature. If I increase the temperature, the vapor pressure is going to be more because there will be more particles of gas building on top of the surface, creating more pressure. What happens to vapor pressure when the temperature increases? Again, the vapor pressure is going to be increased. Now, next, let's look at the phase diagram, where it includes lot of points that you really need to be aware of. So, consider the phase diagram of water below to answer the questions. I want to give you a piece of advice before you start giving any answer. Locate on the graph the 1 atmosphere. Locate on the graph the point of intersection of 1 atmosphere with the first curve and the point of intersection with the second curve. Because at 1 atmosphere, the temperature we have is the freezing point or melting point temperature, and the temperature at 1 atmosphere, the intersection, this one, is the boiling temperature. So what variables are plotted on a phase diagram? In the phase diagram, we plot the pressure versus the temperature. So the variables are the temperature and pressure. What phase of water is represented by each of the following parts? You need to remember that this is the solid phase. So that is the solid phase. And that is I'm going to change the color, the liquid phase. Over here, this is the area of liquid phase. And this is the area of gaseous phase over here. After the point E, the substance will exist in two phases, in equilibrium, in two phases of liquid and gas. So here is the gas. So 1 is solid, 2 is liquid, and 3 is gas. What does point C represent? Point C represents the normal boiling point of water. I would like to point that T2 is the boiling point of water. That's the temperature. That's the normal boiling point, and that's the boiling point temperature. Now, next one. What does B represent? That is the normal melting point of water. So that is the normal melting point of water because it's at 1 atmosphere. And this is the melting point temperature on the graph. What is point A called and what does it represent? A is the triple point. It is the point where I have the three phases existing together. So it represents the temperature and pressure at which water coexists in three phases, like they are all in equilibrium with each other: solid, liquid, and gas. Topic 4.3. In this subtopic, you need to know the difference between the representative units of a molecular compound, or what we also call a covalent compound, and the representative unit of an ionic compound. So always keep in mind, a covalent compound has a representative particle named the molecule, and an ionic compound has the representative particle called formula unit. Now, you don't have to remember all the covalent compounds that you have. You can simply use the periodic table. And when we give you a compound, like for example XY, and go and check the location of X in the periodic table. If X is a non-metal, then definitely Y would be a non-metal, and you are dealing with a covalent compound. But if you checked at the compound given to you in the question, X and Y, and you found out that X is a metal, then definitely the question is dealing with an ionic compound. Let's see how it goes. AN is the representative unit of a compound of CH4. In the periodic table, we find C to be over here. So it's within the non-metals. And also hydrogen is also placed with metals, but it is considered a non-metal. So therefore, I am dealing with a molecule. What is the representative unit for the compound magnesium chloride? Mg in the periodic table, you will find it in group 2, so that is a metal. So here I have a formula unit. Which of the following, again, is an ionic compound? So carbon, we just said that this is a non-metal. Potassium K, I can find it in group 1 of the periodic table. That is a metal. Nitrogen is in group 15 of the periodic table. That is a non-metal. And sulfur is in group 16, also non-metal. So that is the only one that having metal and a non-metal, and it is an ionic compound. Remember, you need to check the periodic table. You don't have to check both, only check the first element. It would be enough. Which of the following compounds is molecular? So they mean which of them is covalent. So let's look at the periodic table. N, non-metal. Aluminium, group 13, metal. Sodium, group 1, that's a metal. Barium, group 2, that is a metal. I'm going to try to show you here. How do I know where's the side of metals and where's the side of non-metals? So hydrogen is a non-metal, and all of this almost area are non-metals. Okay, now you have the metalloids in between, which is fine. Yani, I can consider them, if they come, I can like do it, consider the compound as a metal, and the rest are metals. So this is how they are located. Okay, let's continue. Now, explain the difference between covalent bonds and molecular compounds and ionic bonds, etc. So, both can form a bond through the transfer. When they tell me a transfer of electrons, it means that we are dealing with an ionic compound. So I need to choose the two atoms that gives me an ionic compound. So I need to choose a metal and a non-metal. So I'm gonna choose magnesium and sulfur. Electrons are shared between. When they tell me shared, it means they are talking about a covalent compound. So a covalent compound here is gonna be between two non-metals. So I'm gonna choose so this is metal, metal, metal. So hydrogen and oxygen are the only non-metal. So shared, it means we're talking about a covalent. So I need a metal and a non-metal. So two non-metals. Next, about bonding in water and sodium chloride is true. So they are asking me how the atoms in water are bonded and how the atoms, the Na and the Cl in sodium chloride are bonded. So we know that water is H2O, is a covalent, it's a molecular compound, and an ACl is ionic. So definitely they don't both involve the same way of electrons. So one is sharing electrons, which is water, and sodium chloride involves transferring of electrons. Why does methane, which is a molecule, exist as a gas at room temperature. In these kind of questions, you need to list in your mind the intermolecular forces available. So CH4 is a non-polar molecule. Therefore, the intermolecular forces involved here are London dispersion forces, which are the kind of weak intermolecular forces. And this is why this molecule exists as gas, because its intermolecular forces are weak. So they're not strong enough to make it liquid. So it's not a metallic bonding. It definitely doesn't form hydrogen bonds. It's not an ionic compound. It's a molecule, and the molecules are held together by the weak London dispersion forces. Which of the following explains why magnesium oxide, which is ionic, has high melting point? Okay, let's first think about magnesium oxide. Magnesium oxide has a crystal lattice of Mg2 plus and O2 minus. Usually, ionic compounds, they have very strong electrostatic forces in their crystal lattice. So their forces are very strong. They are the kind of ionic bond forces. To break these or to separate the ions in the crystal lattice, you need to overcome these strong forces. Therefore, the melting point of magnesium oxide is going to be very high. Now, if in the question they come and they tell you to compare between the melting point of MgO and NaCl, you need even also here to involve the charges. The crystal lattice of MgO is stronger because the ions involved are even larger, or not larger, sorry. They are stronger in their force, in their attraction, stronger than the Na plus and the Cl minus. And a force of attraction held between +2 and -2 is double the strength of a force of attraction held by +1 and -1. So if I am comparing, this will have a higher boiling point or higher melting point. So the ions held together by very strong ionic bonds. Which of the following best describes why molecular compounds like methane have low melting and boiling point? It's a molecule. In general, molecular compounds, they have weaker intermolecular forces than ionic. That's one. Second, that's a non-polar molecule. It means it only have London dispersion forces. So we're not dealing with a polar one. So they're not held by hydrogen bonding. They don't have strong ionic bonds. It's not metallic. They are held by weak dispersion forces, which lowers their melting and boiling point. And even at room temperature, they exist as gas. Which of the following is correct comparison of metal and non-metal? So metal, they are known to be good conductors, while non-metals, poor conductors. It's the non-metals that are brittle and the metals that are malleable. The non-metal are dull and the metals are shiny. So these are wrong. And it's also the opposite here. Which of the following is not a property? Make sure you come to the exam knowing the properties of metal. They are ductile, they are malleable, they do conduct electricity. But the only thing that they are not, they are brittle. Brittle is the opposite of malleability. So they're not brittle, they are malleable. Why are metals malleable unlike non-metals? So it's about the structure of the metals themselves. So as you know, in a metal, I have a lattice of positive metals surrounded by a sea of delocalized electrons. I'm going to do the electrons in red. So you have the electrons everywhere. So if there is a force applied over here, it will slide past each other. This delocalized electrons allows this portion to slide like this. So this portion here might go like that, but they will keep their structure. They will hold their structure. Okay? So it's because of the delocalized electrons that allows the positive metals to slide past each other without breaking the structure. Moving on. Which of the following best describes an interstitial defect? Defect is like a problem that comes in the structure of the metal. Usually, we have like 3 types of defect. The interstitial defect is when I have an additional atom occupying a space between the lattice point. Like for example, I have the metals like that. Okay, and suddenly I have an additional one here. So that makes it an interstitial defect. Okay, which of the following describes a vacancy defect? Vacancy defect, like the name it says, it means that there's an atom missing. So for example, in this structure, let's say here, there's an atom here missing. It's empty like that. So it is called vacancy defect. So there's a missing atom from its normal lattice position. Now, the type of defect in the lattice shown below, these atoms are not in their corresponding place like they should be. So this is an interstitial vacancy. Okay? Next, alloy. Which of the following is an example of alloy? Aluminium is a pure metal and they only wrote Al. Copper is pure. Zinc is pure. But when they put steel, they gave you 2 options of atoms. It means that's not pure. So that is a mixture of metal, which means this is an alloy. What type of alloy is steel? Steel is the interstitial alloy. Why? Because I have the iron atoms mixed with carbon atoms. However, carbon atoms smaller than iron atoms in size. So when they come, they cannot replace an iron. They occupy the empty spaces between the metal of iron because C is smaller than iron. I'm going to show you here in the periodic table the location so that you are aware of it. You see here, here's the carbon. Here's the carbon. And here's the iron. So as we go to this side, the atom becomes smaller. Also, as we move down the periodic table, so iron is like 2 more periods above carbon, so it's bigger than carbon. So that's why iron is larger in size than carbon. So when carbon comes to replace or to be placed in the lattice, it will occupy the tiny spaces. Let's continue. Now, the presence of carbon in steel definitely affects its properties compared to pure iron. Look at this structure. If the spaces are filled, then the malleability would be less. And it means the metal or the steel becomes more hard. It becomes harder, less malleable. Now, how much you think carbon is mixed in with iron to make the steel? It's almost by 2%. Memorize this information. So I have like 98% of it is iron and just 2% is carbon. That's the structure of steel. Just small quantity of carbon will make a difference in the properties. Now let's move on to water and aqueous systems. Which characteristics of water is primarily responsible for its high surface tension? All the properties of water are because of the ability of water to make strong intermolecular forces, which are hydrogen bonding. So all the properties, I always have to say it's because of the ability of water to form hydrogen bonds. Which of the following observations results from water polarity and hydrogen bonding? Because water is very polar and have strong hydrogen bonds, they definitely do not move randomly without interaction. Water vapor is denser than liquid. No, usually liquid is denser than vapor. But in the water case, solid is supposed to be denser than liquid, but it's not. So anyway, this sentence is wrong. Water molecules can form spherical droplets because they have a high surface tension. Why does water have a relatively high boiling point compared to similar sized molecules? So for example, if I want to compare HCl to water, HCl is so big. If I want to compare CH4 to water, CH4 molar mass is 16, this one is almost 18. So basically it's pretty close to each other, but this one boiling point is very high, like 100. This one is below 0 Celsius, I think. It becomes gas. And the reason behind that is that water is polar. Water is capable of making strong intermolecular forces called hydrogen bond. So the presence of these hydrogen bonds are the one that make the boiling point or melting point of H2O very high. Which statement correctly compares the hydrogen bonding in water and ammonia? Now, let's think about it this way. H2O and ammonia. Okay? Oxygen. So first, O is more electronegative than N. So here I have a negative partial charge and a negative partial charge, while here I have only one negative partial charge. Also here I have plus positive, plus here I have 3. With the structure of water, one molecule of water is able to do double the amount of hydrogen bonds that an NH2 can do. Yani O will do a hydrogen bond from another hydrogen in a water molecule, and also from this side it can do another hydrogen bond with another water molecule. Whereas nitrogen, I only have one negative partial charge, so it's gonna do one hydrogen bond that is coming from another ammonia molecule. So the quantity of hydrogen bonds coming out in water molecule per molecule are double the one coming per ammonia molecule. That's reason number one. And reason number two, oxygen is more electronegative than nitrogen. So the hydrogen bond is even stronger. So for this reason, hydrogen bonding in water are stronger than those of ammonia. Which of the following is not true about ammonia compared to water? Ammonia has a lower boiling and melting point than water, yes. Ammonia is less polar than water, true. Water is very polar. Ammonia is polar. It undergoes hydrogen bonds, but not as much as water. It does definitely can form hydrogen bonds, but it does not have a higher boiling point than the water. Okay? So again, what I explained up, why does water have higher boiling point than ammonia? Okay? Because the hydrogen bonds in water are stronger than the hydrogen bonds in ammonia. Also, I need to mention that why the hydrogen bonds are stronger, due to the higher electronegativity of oxygen and the presence of two lone pairs of electron around O compared to one lone pair around N. Which of the following best describes a solute in a solution? So to create a solution, we dissolve the solute in the solvent. Together, they make a solution. So here, it's the substance that dissolves in the solvent, not dissolves the solvent. Usually the solute is the one present in smaller quantity, and a solvent is more in quantity than the solute. In a solution, the substance that is present in the largest amount and dissolves the other one is called the solvent. So it's always solvent in more quantity and solute less quantity. Next, consider the diagram below showing the solvation of solid sodium chloride to form an aqueous solution. Look at this crystal lattice. I have sodium chloride as a solute surrounded by water molecules as a solvent. When the solvation process happens, they form a solution. So, who's the solute? NaCl. Who's the solvent? It's water. Is water polar or non-polar? Look at the water. It has partial positive charges and partial negative charges. So water is polar. Explain what happens during the solvation of sodium chloride. You need to explain that the sodium positive ions will be surrounded by water molecules from the side of O, because O is the negatively partial charge, and Cl are surrounded by the one of H plus, H positive side. So an ACl can or will dissolve in water, and H2O molecule starts breaking or separating the ions in the crystal lattice. Okay? In a way that an A plus will be surrounded by H2O from oxygen side, and Cl minus will be surrounded by the H2O from the hydrogen positively charged side. So these are the one that pulls the Cl minus. During solvation of an ionic compound in water, water molecules, they surround, so the water molecules, let's see, they do not surround randomly. So surround ions with positive ends facing cations? No, it's ions with negative ends facing cations. So it is C. Which of the following type of substances is least likely to dissolve in water? Water is polar. Like dissolves like. So any polar compound will be dissolving in water. Any ionic compound can dissolve in water. Now covalent, some of them are polar, some of them are non-polar. So as you can see, I have the polar ones and I have the non-polar ones. So here, the least likely to dissolve is the non-polar. Which of the following best defines an electrolyte? Electrolyte is a substance, is a material. It's a compound that when dissolves in water, it conducts electricity. So it conducts electricity, and here, additionally, due to ion mobility. When an electrolyte is placed in water, it dissociates into. So as I said, electrolyte is a substance that when dissolved in water, it conducts electricity. And why is that? Because when an electrolyte is dissolved, it frees the ions that has in it. So those ions become free. That's why they are able to carry charge, and that's why electricity is conducted. So it dissociates into ions. The positively charged ions in a solution, they move toward the electrode. So if I have a conduction, of course, the positive will move toward the negative electrode, and the negatively charged ion will move to the positive electrode. So it's like oppositely charged particles, they attract each other. An electrolyte is defined as a substance that dissolves in water but never conducts electricity. This means this is the definition of non-electrolyte. Conduct electric current in solution or molten state due to the presence of ions. The ions are the one responsible for conductivity. So that's the answer. Which statement correctly defines the difference between electrolytes and electrolytes in terms of particle behavior? The electrolytes, they free up their charged particles, their ions. Whereas non-electrolytes, they don't have charged particles, they have neutral particles, or what we call molecules. So it's A. Which of the following solutions would result in the brightest glow of a bulb? So in a question like this, we need to look for an ionic compound, and we need to look for an ionic compound or a molecule, probably an acid, for example, that is able to ionize and produce ions. So let's look in this case. Propanol and glucose are both molecular compounds made up of molecules. So they cannot give me a bright glowing, the bulb cannot glow. Now for this one, it partially ionizes in water. So it will give, the bulb will glow, but it would be a weak or a dim light. But the magnesium oxide is an ionic compound that can dissociate totally in water. So when this one is in water, it's gonna give me the brightest glow of a bulb. Which of the following is a weak electrolyte? So again, weak electrolyte, it means it will undergo a partial ionization. Not all the ions will be free, and causes the bulb to glow faintly. Sodium hydroxide is a strong electrolyte. Mercury chloride is a weak electrolyte. Magnesium oxide is a strong one, and sucrose is a non-electrolyte. So the answer is B. Which of the following solutions will not conduct electricity and causes the bulb to remain off? It means we need to choose the non-electrolyte. We need to choose the molecule. So that's ionic, not our answer. That's a molecule. Look, all of these are non-metals. These two are ionic. So the answer is B. Again, a weak electrolyte. A weak electrolyte ionizes partially. So it's gonna give me ions, but the ions are going to be just a little bit in the solution, not full ionization. So just a few. Now, which of the following is a weak electrolyte? Now, I want to point at something here. Whenever I have an acid, hydrochloric acid, sulfuric acid, acetic acid, all the acids are electrolytes. But some of them could be weak and some of them could be strong. So hydrochloric acid is known to be a strong electrolyte. Sulfuric acid as well. Also nitric acid is a strong electrolyte, or perchloric acid. Remember these names. All of these are strong electrolyte. Now acetic acid is the vinegar. It is an acid, but it's a weak electrolyte. Another example would be, for example, carbonic acid or fluoric acid, or a very common one, phosphoric acid. So all of these are considered to be weak. Now, potassium chloride and sodium hydroxide are very strong as well. So the answer here, acetic acid. Now remember the other examples that I gave. Carbonic acid, fluoric acid, and phosphoric acid in terms of acids are weak. But the others like hydrochloric acid, sulfuric, nitric, and perchloric are strong. Now let's move on to hydrates. You need to remember some examples of hydrate, and the best one known is copper sulfate pentahydrate. So keep that in mind. That is a hydrate. What is efflorescence? Efflorescence is when I have a hydrate and the hydrate is dried and release the amount or the molecules of water in it. At this point, when the hydrate releases the water in it, it reduces in mass, it changes color, and it becomes something called anhydrous. So, efflorescence is the release of water molecules from a hydrated compound. Now, the absorption of water from the atmosphere into a compound is the opposite of efflorescence. It's the opposite. It's when hygroscopic compound absorbs water to turn into a hydrate. So the answer is A. Which of the following compounds is known for undergoing efflorescence? So we need to choose the hydrate, the one that contain molecule of water in it. So again, here's another example of a hydrate that you can remember for your exam. What happens during efflorescence? The hydrate loses the water molecule, changes color, and decrease in mass. Now, the final topic that we have is the mole concept. Remember, in your exam, you're gonna have the formula sheet. You can use this formula to help you solve the questions. So I'm just gonna give you a hint. What are the formulas given to you? They're giving you Avogadro's number, and that is equal to 6.02 times 10 to the power of 23. Avogadro's number is used to count the amount of representative particles. So if I want to count how many representative particles I have in a mole, so let me just make it clear. Avogadro's number is equal to this one, and it's equivalent to 1 mole. Remember, the same concept of dozen. When I say 1 dozen, that it means 12 pieces. When I say 1 mole, it means 6.02 times 10 to the power 23 particle. What could a particle be? A particle is a representative particle. It could be a molecule, it could be a formula unit, or it could be an atom. So the formula that we use is Avogadro's number. Make sure that you remember this one, and make sure that you remember that the number of representative particles is equal to the number of moles represented by N multiplied by Avogadro's number. So let's see how we're going to use this formula. So which of the following best describes the definition of a mole? The amount of a substance that contains 6.02 times 10 to the power 23 particles. So that is the answer. Now, calculate the number of atoms found in 5.23 moles of sodium. So they want us to find the number of atoms. Atoms means representative particles. So the number of atoms is equal to the number of mole multiplied by Avogadro's number. So that is going to be 5.23 times Avogadro's number, which is equal to 3.15 times 10 to the power 24 atoms of sodium. Remember, as if like I'm telling you, I have 5 dozens of eggs, and I'm asking you how many pieces of egg I have. So you're gonna take the amount and you're gonna multiply it by what dozen means. It means 12. So that's what it means. And here you have 5 moles of sodium atom. They just wanna know how many pieces of atom this means. So you take the 5.23 and you multiply it by how much the mole is, which is 6.023 times 10 to the power 23. If a sample contains 3.15 times 10 to the power 24 atoms, this is a representative particle. So I have the representative particles. They just want to know how many moles these are. So 3.15 times 10 to the power 24 equals the mole by Avogadro. So in this case, we're going to divide by Avogadro's number on both sides. Solving in this, we're going to get 1.25. Now, the other formula that you have that is provided to you in your formula sheet is the mole N is equal to a mass, symbol small m, over the molar mass. Now let's talk about units. The mole is in mol, the mass is in gram, and the molar mass is the gram per mole. So calculate the number of moles. It means find N. That you have enough 45 grams, this means that they gave me M, mass of sodium. However, every 1 mole, so the molar mass, that's what it means. Every 1 mole of sodium, they have a mass of, or they weigh 22.99 grams. So every 1 mole of sodium, their mass is going to be 22.99 gram. This is the mass that I get from the periodic table. So if I have a 45, how many mass that would be, how many moles this would be. So mole is the given mass over the molar mass. And the answer is going to be 1.96 moles. Moving on. If how many grams calcium are present, how many grams of calcium, it means they are asking me to find the mass are present in 2 moles of calcium. That is N. Again, 40.08 gram per mole, that's the molar mass, which means every 1 mole of calcium, they weigh 40.08 gram. So the 2 mole of calcium, how much they're gonna weigh? You already know the answer, or I can do this formula. So I'll put here 2 mass and the molar mass. So I multiply them. It's gonna be 80. And the final question, what is the mass of 1 mole of hydrogen atoms? So I have 1 mole of hydrogen atoms over here. What's the mass? Knowing that the mass of a single hydrogen atom is 1.67 times 10 to the power negative 4. So the mass of 1 atom is 1.67 times 10 to the power 27 gram. They want me to find the mass of 1 mole. 1 mole contains 6.022 times 10 to the power 23 atoms of hydrogen. So if 1 measures 1.67, then the 6 measures how much? So you're gonna multiply these values together. And here is the answer. Thank you and all the best in your exam.